Welcome to the garden. Today we're going to be having a look at this TB6600 stepper driver. We've got to drive some expansion valves on a great big system to come in. They're EVs, and we need to borrow control of them from the system, which isn't going to be very happy about it. So we need some of these stepper drivers that will do 24 volts, and I thought we'd have a look at it today. So what we're talking about is this sort of thing here. Now this is a 12 volt LEV, EEV, whatever you want to call it. It's basically the stepper coil on here and then the bit inside the pipe that acts on the refrigerant. And usually this cable would be pulled up and it will go onto the PCB, which is up there somewhere with this system. But I've already interfered with it, so it's not. But even though this is a 12 volt one, when we're talking about adjusting an EEV on a refrigeration system, it's a very similar thing to this, which is on a heat pump water heater. Only the system we're doing is a lot bigger than that, but it's the exact same as this. I just don't have a better example at the moment. And there's nowhere obvious to open it. Oh, safety. Ow. Prodded myself in my eyes with my safety glasses. Okay, we're in. Is that melted? No, it's fine. Okay, there we go. She's free. Right, so I think we want 200 steps. We're at 1.8 step angle, I think, from the data sheet that I looked at of the valve, but it isn't obvious. What we want to do is switch 1, 2, 3, 4, 5, 6. Okay, so they didn't start from 0, so they're biologists. So we're going to say switch 1. What do we want? Microstep. Pulses per revolution, which is the steps per revolution. So we want 200. So we want switch 1 on, switch 2 on, switch 3 off. And on is down. And we said that we wanted switch 1 on, switch 2 on, and switch 3 off. Is that right? On, off. Yep. Now the next part, the second 3 switches, we want about 1.5 amps for this. Looking at the data sheet, which isn't altogether obvious or clear because they don't really want you to do this, it looks like it's going to be around 1.2 amps. So I'm going to go with 1.5. Now largely with stepper motors, the faster you do the stepping, which in our case we'll have control of, the lower the current when it's moving. But if you do very, very slow steps, you end up with higher currents because you're essentially getting the really big heavy trolley moving again every time. So you've got to push it, wait for it to stop, push it, wait for it to stop, push it, wait for it to stop. And that's high current. So we're going to go with 1.5, which is on, off. 1.5 on, off, which is the same as the 200 we had, so that's very confusing. So we can just mimic this on the other side, on, off. So we're on, off, which is 200 steps per revolution. If you've got a different motor or whatever, you have to look at this and work that out for yourself. And then for the current, we've got on, off, which is on, off, which is 1.5, and that's what we want. So we're going to try and hook this up in. Sorry, I just noticed it comes with a free white powder. We'll give that the taste test or something similar shortly. So we want to hook this up, and because I've used these before, I haven't have some pre-made wires that I've used previously. Right. Well, at least we know that one's out. In you go. Right, what we'll do is we'll come back and we'll get it hooked up. We'll just have a very quick whiz through this code, which is really short and simple for the TB6600 driver. So we've got the pulse pin connected to pin 2 on the Arduino, direction pin, pin 3, enable pin, pin 4. Into the setup, all 3 of those are outputs, obviously. Enable pin you write low to enable the motor in this case. If you write it high, it disables it, so you need to make sure you have written it low, or I guess you could just tie it to ground, it'll be fine. You don't need the serial for this, but I always put it in just so that you can connect and check it and make sure your program's loaded, so if it doesn't work properly, you know, or you'll know the program's loaded and it's something in the code or the hardwire, or the hardwiring that you've done, rather than it being like an Arduino not starting problem or something. Steps per revolution, 200, which is what the stepper motor we've connected to it is. I've set a delay time of 5 milliseconds, which is kind of sensible for a stepper. If you're using EEVs in refrigeration, they're typically around between 5 and 15, depending, milliseconds between each step. Then, very simple, we set the direction pin low. We do 200 steps, and we're pulsing the pulse pin, or writing it high, delaying, writing it low, delaying. And then we keep on looping through this loop until we've done a whole revolution one way. We then digital direction pin high, which will mean we'll rotate the other way, and then we just do the exact same thing again, and that gets us back to where we started with it. So straight back over to it, and we'll see it in action. So just before we run the code on this, what we'll do is we will put, one thing. I had to change over the blue and the red wires on the TB6600, because when I opened this stepper motor, what I found is instead of the last one that I used that was very similar to this one, if not the same model, was black was A+, green was A-, blue was B+, and red was B-. So as you went from, if you went down, you went A+, A-, B+, B-. But on this particular model that they've sent, which presumably I ordered, it's actually A+, B+, A+, B+, B-, A-, B-. So the order was slightly different. So I've swapped the wires around here so that these wire colours match up with the stepper wire colours. So what we'll do is we'll power this up, and we'll make sure we're getting 12 volts here, because these cables are a little bit long and thin. Well, it's just over 12 volts on my power supply, so there should be a little bit above. Yeah, it's perfect, 12.3, that'll do. So we've got the code on the Arduino, not Arduino. So we plug this in, and then what's going to happen is we think that this stepper motor is going to spin in one direction and then the other direction, and then it'll just keep on repeating that. So we'll unplug it, because that'll be really boring to watch more than once or twice. That's one way, it's back the other way, that way, that way. So that's working exactly as we intended, and it's just over 2 amps, which is kind of what you'd expect. So looks like it works a treat. Dead easy as well. We didn't have to write any tricky code or anything like that. So let's get these out, because we can. And turn the power supply off first, right? Most important thing about electricity is that you do it live. Oh yeah, the other thing is that we did have to change the dip switches, and I put the current up to off on, which is 2.5 amps with a peak of 2.7, because, well, that's what we were getting, and when I looked at that stepper motor, I realised I was going to have to put it up. So yeah, there are a couple of changes since we put it together. We increased the current settings, which is why you get the table and the dip switches, so you can do that. and we had to change the wires over because the stepper itself was wired slightly differently to the previous one. So let's just have a quick look inside this because it looks quite easy to take apart. And if you are going to consider doing this, I'm using a JIS screwdriver here, which I can't remember which size it is, but it looks like it's... No, I can't remember the JIS sizes. Sorry, not sorry. Hey, at least I'm outside Japan and I've got a JIS screwdriver, because I've taken a carburetor off the bike together. And also put it back together, more importantly. Well, more importantly to take it apart to clean it, but then more importantly to put it back together if you want to use it again. So that's just a... I don't know what that is. I guess it's aluminium just because it feels really light. That's probably Ali. And of course Ali's good heatsink material. That's the printed crapstick case. Ooh, squishy, well then you'd expect it, right? A couple of mold marks, doesn't look that bad actually. No, I don't know what any of those things are. There's your dip switches. Is that heat sinking? Oh, can't tell, don't know what that is. Well, I'm looking at this and I've got absolutely no clue what any of this does. But it's one board, nice and simple, so there can't be much to go wrong. I suppose the thing to do is we just put it back together and carry on. It's in. Unfortunately, this JIS screwdriver in particular isn't magnetic. My magnetic set is elsewhere. It's typical the first time you use it in ages, you don't have the magnetic one. But also typically for taking apart Mikuni carburetors, you don't need a magnetic one because all the screws are very easy to get to. And you don't have any depth like this to have to get your screwdriver past without them falling off. I suppose what we do is, having opened it up, is to have a quick look and realise that we don't know anything about anything, frankly. We'll just plumb it back in and make sure that it works. Because otherwise I'll forget that I've done this and I'll go to use it and then it won't work. I have to send an angry email to the people I got it off and then I have to send a very painful apology afterwards for messing them about because of my own stupidity. Alright, that's back together. Power on. No smoke or bang yet. Yeah, one way, back the other way. Oh, perfect. That's all she wrote.